Right. Before getting into the op-amp circuits, you should know the circuit symbol used to represent an op-amp. Fundamentally, you have three terminals: non-inverting terminal, non-inverting terminal. We will denote it by V plus, V for voltage at non-inverting terminal, V minus, that is voltage at inverting terminal, and there is an output signal line out. Right? These 3 points, 3 lines are important while representing an op-amp in any circuit. Along with this, sometimes you will represent positive supply rail and negative supply rail voltages. Right? To ensure a symmetrical swing, we usually select same magnitude for positive as well as negative supplies. Nothing wrong if you are connecting a 0 volts or a ground signal to your another or negative rail. Nothing wrong. It implies the output can go up to plus VCC maximum to 0 if you are connecting 0. If you are connecting minus VCC, implies output of the op-amp can be anywhere between plus VCC to minus VCC. But it cannot go beyond these two levels. In the other way, maximum value of the output is restricted by the supply voltages. Right? Hold a moment. Somebody is asking to join. So this is a circuit symbol. Other than this, actually we have a few more lines, and that you will get to know after discussing the parameters of an ideal op-amp. Right? So supply voltages we need not show always. Okay, we will show them if required. Right? And the properties of an ideal op-amp. If the op-amp is ideal, we have 6 properties here. First one is infinite input impedance. Infinite input impedance implies current flowing into the input terminals of the op-amp will be how much? 0 amperes. So current into the terminals, minus or positive, will be always 0 amperes, because input impedance Rn is input. If you are looking into positive input, you will feel an infinite input impedance. If you are looking into the inverting input, then also you will feel an infinite input impedance. Implies the input terminals of your op-amp never going to draw current from your input circuitry. The moment op-amp is not accepting the input current, we can say that op-amp is a voltage controlled device, because it never draws the input current, so you cannot control the op-amp by applying current sources or current signals at the input side. So it's a voltage controlled device. Right? So Rn infinite. Right? Rn infinite. Right. Then second property is 0 output impedance. R out equal to 0 ohms. Implies if you are looking into the output node of your op-amp, R out, you will feel a 0 output impedance, 0 ohms. Right? As all of you knows that an ideal voltage source has an output impedance of how much? 0 ohms. So your op-amp can be modeled as a voltage source at the output side. So input it is a voltage control device, output it is a voltage source. So effectively, the device, ideal op-amp or generally op-amp, is a voltage controlled voltage source. VC, Vs. Since it is a voltage controlled voltage source, its output can be modeled as a voltage source, right, with zero series impedance, 0 ohms, ideal source, and that is your out, right? And the value of that output voltage is nothing but differential gain multiplied by the difference in positive and negative input terminals, right? That implies your op-amp always amplifies the difference in the signals V plus or signal at the non-inverting input minus signal present at the inverting input by a gain AD. That AD is called differential gain. Differential, right? And of course, there is the question that why it is amplifying a difference in signals. What is the requirement for that? Why it is not amplifying a common signal present at its input terminals? The answer is very simple. Always common signals implies noise. If you are keeping your op-amp in an atmosphere, there will be a noise, and that noise will be common for both the negative as well as positive input terminals. So if your op-amp is amplifying that noise, and then your output will be also having noise. That is not required, right? We always would like to eliminate, reject, or suppress or filter out the noises present in the atmosphere. So it's a novel device that perfectly eliminates the common signals, or the other way, noises present in the signal. So if your op-amp is an ideal one, you can say that its gain should be infinity. If it is an ideal one, it will have infinite differential gain. A for gain, D for difference. Right? D for differential, A for gain, voltage gain. Because it's a voltage controlled voltage source. Voltage quantity at the output side, input also voltage. So output by input is the gain. That gain is called differential gain. And what about the common mode gain? AC ideally. Ideal requirement is to suppress the noises present in the atmosphere or in the circuit completely. So there should not be even a 0.0001 amplification for noise. So ideally it should be 0. Noise should not be present, or common signal should not be present at the output side. Ideally. So based on these two conditions, we have a parameter called infinite common mode rejection ratio, or CMRR. That is defined as differential gain on numerator upon common mode gain on the denominator. Ideal case, that will be equal to n. Because differential gain we are expecting infinite and 0. So ideally CMRR, common mode rejection ratio. It is the ability of an op-amp to suppress the common signals present at the input, along with the ability of a given op-amp to amplify the difference in signals V plus minus V minus present at the input terminals, right? So that is common mode rejection ratio, CM. The fourth point is important. with respect to frequency of oscillation, so frequency of operation, that is slew rate. Slew rate is R, and bandwidth. Slew rate and bandwidth. Right? Slew rate is nothing but it's an important parameter that will be available with the data sheet of your operational amplifier. See, slew rate is nothing but maximum possible change at the output upon change in time, or the maximum possible change of output signal with respect to time. dV out by dt, I should write a max value, that is maximum possible rate of change of output with respect to time is called slew rate. And ideally, an ideal device should perform equally well in a frequency range from omega equal to 0 to omega equal to infinity. So if your op amp is an ideal one, we will take the bandwidth of the device as infinity. That implies frequency of the input signal won't have any effect on the response of the op amp. Suppose your op amp is functioning as an amplifier. If you're feeding a 1 Hz signal, if your output is a 2-volt signal, if you are keeping the same amplitude at the input side and you are increasing your frequency to 2 megahertz, then your output amplitude should be same as earlier, that is 2 volts, for example. So it should not distinguish between the frequencies. It should accept the entire band of frequencies, ideally from 0 to infinity. So higher frequency is infinity. So we'll take it as bandwidth equal to NC. Right? Then fifth point may not be familiar to you with one: zero input offset and output offset voltages. So to understand that, we should understand what is an input offset and output offset voltages. That is also quite simple. Input offset voltage implies if you want to make your V out equal to 0, ideally you can short the input terminals. You are expecting a 0 at the output side. Sometimes you may not be getting a 0, V out not equal to 0, right? So that voltage is called output offset voltage. The voltage present at the output side of an op amp when its input terminals are shorted together. Ideally, I'm expecting a 0. So ideally, output offset voltage should be 0. What about input offset voltage? Input offset voltage is nothing but if you are observing a non-zero value at the output, if you are shorting the inputs, non-zero value not equal to 0, then you have to connect some voltage either at positive input or at negative input with other terminal ground, right? Polarity and all will be different for different kind of amps. So in a broad sense, the input offset voltage is the voltage to be applied in series with the input terminal. That terminal can be either negative or positive, doesn't matter. That is called input offset voltage. The voltage to be applied at the input side to make Vout equal to 0. Ideal case, our Vout equal to 0, so you need not apply any offset voltages. That implies input offset voltage also will be equal to 0 in ideal sense. Right? Sixth one, and that we are not dealing with, is an infinite power supply projection ratio, PSRR, and that we are not going to discuss. Right? That's a definition. Infinite power supply rejection ratio. It's nothing but change in power supply on numerator upon change in output signal due to that change in power supply. So we are expecting a zero value at the denominator. There should not be ideally any change if your power supplies are fluctuating. Output should be constant. That should be based on V1 and V2 or V plus and V minus and the gain of the ramp. So it should not depend on the power supply fluctuations. Of course, power supply should be present in the circuit, but change from plus VCC or minus VCC upward or downward for a slight margin won't affect the performance of my ramp. That is an ideal case. So denominator will tend towards 0, ideal behavior. I will have an infinite PSRR, power supply projection ratio. These are the parameters we have to extract while solving the circuits. And in that, important cases are infinite Rin because 0 current into the fan and 0 output impedance. And the third one, infinite differential gain. Okay, so this is actually infinite. So infinite multiplied by a positive quantity plus infinity. Infinite multiplied by a negative quantity minus infinity. So if V plus is greater than V minus, your output will be positive. Positive large, ideally positive infinity. If V plus is less than V minus, this difference will become negative. You will have a negative output. So it's least one minus infinity. But actually in our circuit, never will get plus infinity or minus infinity. The output will be restricted by the supply voltages plus VCC or minus VCC. Then you will be having so many doubts in your mind. If you are using an op amp as an amplifier, since the differential gain is infinity, I will get a plus VCC or minus VCC depending on the polarity of V plus minus V minus. And that case, output is independent of the input signal you are going to apply. Right? Should be dependent. Amplifier implies V out should be proportional to V in always. But what we discussed right now is output is always at plus VCC or minus VCC because gain is infinity. Based on the polarity of the difference between V plus and V minus, I will get either plus VCC or minus VCC. But if I'm using it as an amplifier, I should get a value V out that's a function of my input signal or signal applied at V plus or V minus. That will address in the coming sessions. Okay, these are clear properties of an ideal op amp and how to model the op amp. If you are modeling your op amp, you can draw it decently like this. You'll have V plus here, V minus here, and output is nothing but a source, voltage source, right? This is my output. Now series resistance, its value is nothing but differential gain multiplied by how much? Positive input V plus minus negative input V minus. That's it. So it's a voltage controlled voltage source. Dependent voltage source. AD times difference between the input voltages. Right? So it's a voltage controlled voltage source. And your concerns, whether it will go to infinity or plus VCC or linearly varies with V plus or V minus, that we will address in the upcoming sessions. Any doubts? Right, sir. Noise echo issue. One second. Hold on a moment. Audio clear ആണോ നേരത്തെ അയച്ച മെസ്സേജ് ഞാൻ ശ്രദ്ധിച്ചില്ല സോറി ഒന്ന് ചാറ്റ് ബോക്സിൽ റിപ്ലൈ ചെയ്യോ ഓഡിയോ ഇഷ്യൂസ് ഉണ്ടോ ഇപ്പോഴും ഇഷ്യൂസ് ഉണ്ടോ ആരെങ്കിലും ചാറ്റ് ബോക്സിൽ പറഞ്ഞ് ഓഡിയബിൾ ആണോ yes okay okay right okay. Oh, right. So in your op-amp circuits, you have three different classes of connections. Let us mark it as case 1, case 2, and case 3. Right? Case 1 is an open loop condition. Open.
So chat box question vannundu.
Right. Last property. Thank you. Right. Last property. Okay. Right. Last property was infinite power supply rejection ratio, and that is defined as change in power supply on numerator divided by the change in output voltage, and numerator is the cause and denominator is the effect, and we are expecting no change at my output even though your plus or minus VCC supply voltage is fluctuating from plus VCC or minus VCC. Let us say plus VCC slightly going up or coming down plus in line. This is a VCC line. If my supply is increasing from VCC, my output should not change. Based on that, my output should change only with respect to my input signals. So I'm expecting a zero change at my output based on a change in power supply line. Is that clear? It's just a definition, that's it. All right. So we have three different cases here, case 1, case 2, and case 3. Right? Case 1 is an open loop case, open loop condition, open. Case 2 is a negative feedback case, right? The feedback signal appearing at the negative input, so I will call it as a negative feedback. Third case is a positive feedback case in which feedback signal from the output node connected to the positive inputs. Right. So as we discussed, the output voltage can be expressed as V out equal to difference in positive input and negative input, V plus minus V minus, multiplied by differential gain AD. So rearranging the terms, output upon AD will give you V plus equal to V minus. As we discussed, if AD equal to infinity, if your V out in the numerator is finite, and AD equal to infinity implies this ratio will tend towards 0. That will give you V plus minus V minus equal to 0. That will give you V plus equal to V minus. But that is not true. As you can see this, if I'm connecting a plus 2 volts here, a plus 1 volts here, my V plus and V minus should not be same. So it happens because in the open loop case, if you are having a plus infinity and a minus infinity supply voltage is practically impossible, but let us assume for the sake of explaining this. So your output will be goes to infinity, or your output depends on the supply voltage VCC. VCC is extremely large. V out also equal to large. So you cannot expect V out always finite, right? So V out may go to infinity if you are applying a supply voltage of infinity. You will be having so many doubts based on that. Hold on, it will be clear after explaining circuits, right? Please hold on. So if I am using infinite power supply, ideally, practically it is impossible. I won't have a V plus equal to V minus integration. So I will see V plus not equal to V minus in an open loop configuration, because output is not finite always. It can go up to infinity if my supply voltage is infinite. Hold on. Right. Let us get into the second circuit. Right? In second circuit, V plus minus V minus multiplied by AD will give you your V out as we discussed here. And my V plus is V plus itself. V minus I have connected to V out. Right? So V plus minus V out times AD equal to V out. Rearranging the terms, I will have an expression for V out. It's equal to V plus multiplied by AD upon 1 plus AD. As AD tends to infinity, this output will tend towards V plus itself. Because as AD tends to infinity, numerator AD, 1 plus AD will tend towards infinity, denominator AD infinity. So both will cancel, so V out equal to V plus. Right. Or the other way, if you are writing your output as from equation number 1, V plus minus V minus from first equation here equal to V out upon AD, similar to this, right? And if V out is finite, then you can say that V plus minus V minus equal to 0 if AD is infinite. And we don't know whether it is finite or not. Implies if I'm applying a plus infinity or a minus infinity or both at a time, my output V out should be finite. Then I can say that this ratio will goes to 0. Implies V plus equal to V minus, or V plus minus V minus equal to 0. Let us see that. My supply voltage is plus infinity, right? Suppose my input, V plus input, is going up, positive. A positive increase will increase my output VO towards positive side. That positive increase is coupled at the negative input. Negative input increases. An increase in negative input should decrease my output, because increase in negative V minus should decrease my output. That decrease is available again at my negative. A decrease in negative input should increase my output. That increase is again available at my negative. So output should decrease. Right? So even though if you are applying a plus infinity or minus infinity, due to the negative feedback, due to the corrective mechanism in the circuit, output will be in a particular range. Never goes to infinity. Still, you will be having some doubts. Hold on, that will be cleared after explaining case number 3. Right? So here we concluded that even though if I am giving a plus infinity, my output is always finite, never goes to infinity. So V plus minus V minus equal to 0 implies V plus equal to V minus. Hold on, we will discuss third case also. Right? Okay. In third case, I have interchanged plus and minus. Feedback is to positive, positive. And if I am writing the output signal, AD multiplied by positive input, that is V plus, minus V minus. Positive input is nothing but V out, since it is connected to output. And if I am rearranging the terms, I will get it as V out equal to V minus if AD tends to A infinity. AD minus 1 will be approximately equal to AD if AD is very, very large. And from based on first equation, similar to case 2, I have V plus minus V minus equal to V out on numerator upon infinite AD. Right? As earlier in case 2, if V out is finite always, my V plus minus V minus should be 0 because I am having an infinite AD in ideal case, right? And I should ensure that even though if I am applying a plus infinity, minus infinity, practically not at all possible. So if I am applying a large value at supply lines, VCC and minus VCC, whether my output will be finite or not, that can be easily identified based on what we discussed right now. Suppose here is going up, minus 4 up. An increase in the negative input should decrease my output. That is obvious, right? And that decrease is coupled to the positive input. Please listen, positive input. Output decreases, positive input also decreases. That will decrease my output further, right? And that further decrease is coupled to the positive input. Positive input further decreases. Then have further decrease in my output. That decrease is again coupled to the positive input. Positive input again decreases. I will have further decrease. So after some time, let us say transients, after the initial transients, my output will reach minus infinity if I am applying minus infinity in place of minus VCC. Or I will say that after some time output is saturated to minus VCC. And you will be having a doubt in mind that if input is not changing up, if input is changing down, what will happen? If input is changing down, negative input decreases, my output will increase. That is obvious. V minus decreases, my output should decrease. So output should increase. That increase is coupled to the positive input. My output further increases due to an increase in positive input. That further increase is again coupled to the positive input. Output further increases. That further increase is available here as a feedback signal. Then my output further increases, eventually it reaches at plus infinity if I am giving a plus infinity. So case number 1 and case number 2, you cannot say that V out is always finite. You cannot say that. But in case number 2, you can always say that your V out is finite here. So finite upon infinity will give you a 0. That will give you a condition V plus equal to V minus. So case number 1 and case number 3, V plus never equal to V minus. V minus. Case number 2, you will have V plus equal to V minus condition. And while solving the circuit, if it is in case number 1 and case number 3, we don't have any issues. We need not do anything. Blindly, you can say that output here is at plus VCC or minus VCC. That depends on the polarity of V minus. Right? In case 1, also you can say that output is either at plus VCC or minus VCC, depending on the values of V plus and V minus. If V plus is larger, it will be at plus VCC. If V minus is larger, that will be at minus VCC. Or the other way, we will say that circuit number 1 and circuit number 3, the output signal is saturated at either plus VCC or minus VCC, depending on the polarity of V minus here and the values of V1 and V plus and V minus. Whereas in your case number 2, output is always finite, so this ratio will give you 0. V plus equal to V minus condition is satisfied in case number 2. So case number 2 circuits involves negative feedbacks. In that condition, you should apply 2 conditions. What are the 2 conditions? First condition is valid for all. What was the first condition? Input current equal to 0, input current equal to 0, input current equal to 0, input current equal to 0. That is valid for all 3 cases. V plus equal to V minus is the second condition that is valid only for negative feedback circuit. And this is required to analyze all kind of circuits that involves ideal op-amp. Is that clear? Any issues? We have to rectify this proceeding to the next stage. Any problems, any issues? Please reply through chat box. No problems. Right, not Skopichi and time one. Right, I will hold. No issues at all. We have plenty of time. No problem. Can you repeat the first condition? Right, I will do that. I will repeat first condition. Anything else? Right, just a statement. Okay, right. If we are applying our common sense, we can now never say that V plus equal to V minus in case 1, because V plus is an external voltage source, 2 volts, let us see. V minus is also an external voltage source, let us say plus 1. They are not same, right? So in case 1, it is an open loop configuration. Output suddenly jumps to plus VCC or minus VCC. So you cannot say that output is always finite. That depends on the value of VCC. But in case number 2, that never depends on the value of VCC. It will be in a finite interval that depends on actually the value of V. So V plus not equal to V minus is in case number 1, because V plus minus V minus multiplied by infinity AD will go in denominator, right side is V out by AD, finite upon infinity you can equate to 0, but that is not happening here. V out is not always finite, because if you are applying plus infinity, output will be at plus infinity if V plus is greater than V minus. V plus is 2 in this example, so output will be plus infinity. So you can say that always output is at finite. So I will conclude it again. You need not by heart it. It's trivial. V plus not equal to V minus in open loop. V plus equal to V minus in negative feedback circuits. V plus not equal to V minus in positive feedback circuits. Right, Paul B, it's okay. Any other issues? Bharat, not copy though. proceed. Nothing else is to be taught while discussing problems. This is more than enough. Two conditions: input currents are 0, V plus equal to V minus, negative feedback V plus not equal to V minus in the case of positive or open loop configurations. One more case will appear later on, both positive and negative feedback together in a circuit. We'll discuss what to do while solving that kind of problems. That will be better. So, as of now, three different cases. Right. So, let us move to next slide. That is nothing but procedure for analyzing the ideal op-amp circuits. Everything is clear to you. Everybody knows this. What are the procedures you need? First procedure is to identify whether it is a positive feedback or negative feedback. Right? If it is positive feedback, V plus not equal to V minus, output is saturated at plus VCC or minus VCC. That depends on voltages present in the circuit and supply voltage given to the op-amp. If it is negative feedback, V plus equal to V minus, right? And open loop also, that falls under first case, positive or open loop. V plus never equal to V minus. But in all these three cases, one condition is valid, one condition is true. What is that condition? Rn is infinity. So current going into the positive input equal to 0, current going into the negative input is also equal to 0 amperes. That is true. All three cases. And one case is valid for case number 2, that is V plus equal to V minus. So while identifying the output voltage in case 2, V plus equal to V minus condition, you can impose a condition that is V plus equal to V minus to identify the out value. Negative feedback case. Other two cases, output is either at plus VCC or minus VCC. You need not apply V plus not equal to V minus condition. You cannot apply that. But in your second case, you can apply V plus equal to V minus condition while evaluating your output C. And analysis is very simple, very simple. Hardly it will take 4 or 5 seconds to arrive. Right? So just identify the feedback. If it is negative, V plus equal to V minus, based on that condition, you can identify. If it is positive feedback or open loop, you need not do anything. Output can be either at positive VCC or negative VCC. Is that clear? Copied. Properties and condition for virtual short. Virtual short. I will explain why it is called virtual. Heading of the last slide was condition for virtual short. Why it is virtual short? Why it is not actually short? We will discuss later on. So V plus equal to V minus condition is called virtual short. So if you're clubbing I equal to 0 and virtual short, you can solve all problems that is going to appear from with negative. Positive or open, no issues. It's a single answer, either plus VCC or minus. Right. So let us get into inverting amplifier. Actually, name won't have any significance. They won't ask you the name of the circuit. They will ask you what is the output. Right. So I have made a heading that inverting amplifier. I have an amplifier circuit of amp. Which mode it is? Positive or negative? It's negative. Negative feedback. I will mark it as case number 1, case number 2, case number 3. Okay. 3 different circuits. Right. Actually, we are running late by 2 minutes. Okay, no problem. Inverting amp. Right. Everybody knows the output of this inverting amp. What is that? V out equal to minus this resistance RA upon the input resistance RB multiplied by this voltage. How much is that voltage with respect to ground? V. So output is nothing but minus RA upon RB times V. But you can solve it different ways. You need not by heart it. The formula, and this formula will fail here. Here it will work, and if you are asked to identify actual output of the op-amp, let us say V of dash, you cannot go for this given formula. So formula you can remember it, but it's better to analyze the circuit the other way without using the formula, and that will be quick. You can reach your answer quickly, very quick. So let us analyze circuit number 1 in different manner. And anyway, everybody knows that it is output equal to minus RA upon RB times VB. If VB is my input signal, V in, V out is equal to minus of RA upon RB times V in, right? V in. So this is K times V in. So output is linearly proportional to V in, and that linearity constant K is called the ratio of the resistances RA upon RB with a negative sign. Since there exists a negative sign, we will call it as inverting amplifier, but that don't have any significance in the exam. Right? It's inverting because you have a negative sign. That's it. Right? So since it is a negative feedback circuit, the potential at inverting input should be how much? 0 or ground, same as my V plus. V plus is grounded, 0 volts. So V plus equal to V minus is valid. V plus equal to V minus is valid. Right? You can analyze the circuit many ways. Let us say current IB, current IA flowing into that node, and there is no current into the op-amp. So IA is nothing but in this polarity V out, Ohm's law, V out, this end potential minus the potential at the other end of RA, that is 0, V out minus 0. I am writing IA, V out minus 0 upon resistance RA, Ohm's law. Similarly, IB, again Ohm's law. Please hold on, you'll be getting bored, but please listen. This is important. IB equal to V in this direction, V in minus 0 upon RB. Right? And if I am applying Kirchhoff current law, what is the current law? Sum of the currents entering to that node equal to 0. 0 current flowing into the op-amp. So I have to sum IA plus IB equal to 0. That implies V out by RA, that is my IA, plus IB is nothing but in by RB, that's equal to 0. From this, V out will be minus RE upon RB times in as written. Right, that is one method of solving the circuit. And of course, you can directly use this formula, no issues, right? But always that formula never going to work, right? So it's an inverting amplifier. Gain is minus RA upon R. The same configuration I have connected like this as case 2. What will be the output? What will be the output? It's a constant current source, 1 milliampere. Feedback is negative. The moment feedback is negative, you can say that V plus equal to V minus. That's it. Nothing else. What will be the answer? V out in the second case. Case number 2. One milliampere current source, ideal. And inverting, non-inverting input is ground. Answers, second case. Right, Sanjeev says 2 volts, 2 volt, Adina says right, Malavika 2 volts, right, okay, 2 volts, 2 volts, right. Right. So now current flows into the op-amp 0 amperes because op-amp is ideal. Entire 1 milliampere flows through this resistor, right? Right? No other way. 1 milliampere should flow through that resistor, 2K. 1 milli into 2K based on Ohm's law, voltage across the resistance will be current multiplied by the resistance. 1 milli multiplied by 2K, milli K will get cancelled. I will have 2 volts. What is the polarity? Plus, minus. And what is my output? Output is appearing as positive to ground. This is my V out. And that V out we have to find. Right? And what about V minus? V plus equal to V minus. V plus is grounded. So V minus also will be at ground. At ground. Then if you are applying your Kirchhoff voltage law, what is Kirchhoff voltage law? Sum of voltages in a closed loop should be equal to 0. So I have to find V out. So I'm starting from here ground. Negative, positive, I can take it as either positive or negative. I am taking it as a positive quantity. Negative to positive, I am taking as a positive quantity. Right. Then plus minus 2. So I should take it as negative 2. Because negative to positive, I took it as plus. So plus to minus, I should take it as a minus. So minus 2. I have started from ground. I have taken this. I have reached here. This is actually a ground. So it's a closed loop. So equal to implies V out equal to volts. And this formula is not going to work. Of course, you can remember the formula. If you can apply that kind of circuits, you can apply directly. But we cannot expect a question based on that because everybody knows that. And there won't be question based on applying simple formulas. Anyway, here output voltage is equal to positive 2. Any doubts? Everybody got the answer? Any issues? Applying KVL, taking Ohm's law, writing Ohm's law, taking the cross loop. Starting from ground, ending at ground, closed loop, equating to 0. Then my unknown, V out equal to 0. I have applied V plus equal to V minus first, then my KVL along with the input current to the op-amp equal to 0. Any other issues, any problems? Okay or no? Right. Right. Oh, what about the output in the case of third circuit? Third circuit. Third circuit. It's also an inverting amplifier. As we discussed, gain of the amplifier will be RA upon RB, and 2K is in place of your RA, 1K is in place of your RB compared to the first circuit. So minus RA upon RB, that is minus 2 divided by 1, minus 2, multiplied by input signal. What is input signal? Right. Okay, minus 4, right. What is Vin? Vin is nothing but 2 volts. So gain is minus 2, input is 2 volts. So minus 2 multiplied by 2, I will get how much? Minus 4. Directly you can write. Minus 4. Minus. Everybody got minus 4? Right. Minus 4. Any issues? How you got minus 4? By using this formula, you will be having a doubt that whether the same formula is applicable to the circuit because that circuit has an extra DC source. Right. For that, you should look the circuit in different ways. In the second case, how you got it as 2 volts, you got it as 2 because the current flowing through this branch is 1 milliampere, and that current creates a voltage drop of 2 volts, and that will appear here. You got V out equal to 2 volts, right? So if your 1 volt DC source is not present, then it's similar to your old circuit. You will get it as minus 2 multiplied by input, that is positive 2 minus. Or the other way, this is at ground potential. You should be identifying different methods so that while writing the examination, you will feel that this method will be quick enough. Then you have to follow that. Okay. That's why I'm explaining different methods. Right. So if 1 volt is absent, absent or present doesn't matter. Negative feedback, inverting terminal is given. 2 volts minus 0 volts by 1K, 2 milliampere current is flowing. And that 2 milliamp current cannot go into the op-amp, so that 2 milliamps current goes through this. That 2 milliampere makes a voltage drop of how much? Plus minus 4 volts. That's we are getting a answer. Right? So if I am adding a voltage source DC, like this, whether my current flowing through 1K will change? Yes or no? If my 1 volt source is absent, it's very similar to our old circuit. You got it as minus 4, that's true. Current flowing through 1K will be 2 minus 0 by 1K, 2 milliampere. Same current flows through 2 kilo ohm here because now current flows into the ramp. 2 milliampere multiplied by 2K, I will get 4 volts, 4 volts across this 2K resistance. And as earlier, if I am writing my Kirchhoff voltage law, I will get it as minus 4. This is my V out. So negative positive V out, right? Negative positive plus 4, right? Negative positive, I'm taking it as positive. This is also negative positive plus 4. I have started from ground here. here is virtually ground, so I have reached ground. So sum should be equal to 0. Directly I will get it as minus 4. Or using your old formula, minus 2 divided by 1 minus 2 multiplied by 2 minus 4. Both cases is right. And that minus 4 is appearing at the output because the current flowing through 2K is 2 milliamps. If I am adding a voltage source here in series like this, whether my current will change? Current flowing through 1K is decided by this voltage and voltage at the other end, that is virtually at ground. So same 2 milliampere, same 2 milliampere, same output voltage minus 4. Right? And if you are asked to identify what is the actual output voltage generated by the op-amp, actual output of the op-amp, output of the circuit is minus 4. What is the actual output of your op-amp? Actual output in the sense, this will appear like this. I will call it as V out dash. How much is V out dash? This is 1. This is V out. V out, we got it as minus. Minus. So what about V out dash? This is at ground. This is also at ground. So I'm going to write KVL, Kirchhoff voltage law. This is ground, negative positive plus V out. Right? Negative positive plus 1. Then positive to negative minus V out dash. Starting from ground here, negative positive, so plus V out, negative positive 1 volt plus 1 plus minus V out dash. I should take a negative sign, so minus V out dash equal to 0. It's a closed loop. 0 to 0 implies V out dash is equal to V out plus 1. V out is minus 4. Minus 4 plus 1 is minus 3. So V out dash is equal to minus 3. So the actual output generated by the op-amp is nothing but minus 3 to produce output of our circuit equal to minus 4. Is that clear? Yes or no? Irrespective of the presence of 1 volt source, actual output of your circuit will be minus 4 itself. If 1 volt is absent, actual output of op-amp and output of circuit are same, minus 4, not change. If there exists a 1 volt like this, output of circuit is still minus 4 because this current is same, this current is same. And the output generated by the op-amp, actual output of the op-amp is nothing but V out dash is equal to minus 3 volts. Any issues with respect to this? I am explaining this to clarify one more point. Any other doubts? Only if you are replying. Any other issues for others? What about others? Any problems? Right. In third case, if actual output of your op-amp V out dash is asked, you have to go for minus 3, and output of your circuit is nothing but minus 4. Here, let me tell you one more important point. While analyzing the circuit, we are equating V plus and V minus if the feedback is negative. And we are solving the circuit and we are identifying the output as minus 4. That is right. But actually, the op-amp is continuously varying its own output voltage as well as output current, so that V plus equal to V minus is always maintained in the circuit if the feedback is negative. You should distinguish between these two. We are solving the circuit by assuming V plus equal to V minus and we are identifying the output. But actually, in physical sense, op-amp is continuously varying its output voltage until V plus equal to V minus. So hence, just after switching on the power supply, you will not get a -4 here. After a small interval of time, op-amp ensures V plus equal to V minus by varying its own output voltage to which value? To -3 volts. So that this is at -4 volt and the potential at this V minus is 0, same as your flex. Is that clear? We are doing the other way. We are assuming V plus equal to V minus and finding the output. Actually, op-amp varies its own output signal and output current, output voltage and output current, so that V plus equal to V minus is always maintained in a negative feedback cube, right? That is the point to be conveyed. Is that okay? Any other issues? Simple circuit based on KCL, KVL, you can identify the answers. Right? Case 3, once more, can you check? Right. Oh. Right. Case 3, there was a voltage source like this, positive was grounded, 1K, 2K, here, 1K here, and this value was 2 volts. 2 volts. This is 1 volt. The presence of this 1 volt won't affect the current flowing through this resistor. Negative feedback circuit, V plus equal to V minus, so this will be at ground. No current into the op-amp, 0 amperes. So current flowing through the resistance, 1K resistance is nothing but 2 minus 0 by 1K, that is 2 milliamps. 0 current into the op-amp implies same 2 milliamps goes through this, and this is my out. That creates 2 milli into 2K, 4 volts in this polarity. You are asked to identify the out. Blindly, you can write it as -4 because minus 2 divided by 1, that is 2 multiplied by V in, minus RP minus RA divided by RB multiplied by V in. RA by RB is 2, V in is 2, minus 2 into 2 minus 4. Right? Or the other way, that may not be true always. You cannot apply that formula always. In that case, you can identify the current, you can identify the voltage. This point voltage with respect to ground is asked. This is at ground, this is also at ground. So I'm starting from here, negative, positive. I'm taking it as positive out. This is negative, positive again. So I should take +4. And I have started from ground, I have ended at ground. The sum should be equal to 0. It's a closed loop. Implies V out equal to -4. That's it. Very simple. Right. Okay, Chingal and Sheryl. Right. Okay, next problem. We have another problem here. Let us try to solve. Find the value of V. You can tell me your answers quickly. What is V out? And you cannot apply the formula because it's a difference. It's an inverting only, but how much is answer right? Very good. 1. Right. Very good. It's trivial. So we'll have 1 millipoint through 1K. You will have a 1 volt. You are asked to identify V out value. So negative, positive, V out. Plus, minus, -1. This is at ground virtually. V plus equal to V minus. Closed loop starting from ground, ending at ground. -1 equal to 0. V out equal to 1. Now, everybody got 1 volts? It's very simple. What is the actual output of your op amp? Let us say V out dash. How much? V out dash. How much it is? One milliampere current should flow through 1K. That is clear to you. This is also 1 milliampere. That is also true. Right side is open, 0 amperes. So entire 1 milliampere comes from the output of your op amp, or current supplied by the op amp is 1 milliamperes. What about actual output of your op amp? Actual output of your op amp. Everybody, please tell me the answer. This is actual output. This is output of my circuit, and I got it as 1 volts. Right. Is it 2 volts? No. Right. 1 milliampere flows through 2 kilo ohm resistance. So I will have a 2 volts drop across 2K in this polarity, right? 2 volts. So I have to find this. So I'm writing Kirchhoff voltage law. This I know, 1 volt, negative, positive, plus 1. Negative, positive, plus 2. Positive, negative, minus V out dash equal to 0. Done. Actual output, V out dash is equal to plus 1 equal to 3 volts. Very simple, no worries, nothing. The presence of the element here will not change the current going through 1K. If you are inserting, instead of 2K here, if you are inserting 4K, your output will be still at 1, but output dash, V out dash, will change. Right? This will become 4 volts. So V out dash will become 5 volts. So if you are varying the components, op amp will vary its own output so that V plus equal to V minus is maintained always. Right? So answer for that question was, initial answer was plus 1, second answer was plus 3, third answer was plus 5. Right? If you are making it as 4 kilo ohm resistance, 4 volts will drop. So 4 plus 1 equal to 5 equal to V out dash. Yeah. Is that okay? Shall I move to next problem? Right? Anybody having some issues? Because I'm going very slowly. Right? And next class we'll move a little bit faster. Right? Okay. I'm having a non-inverting amplifier. Right. I have a problem here and a simple non-inverting circuit here. Everybody know that the voltage gain is nothing but 1 plus R2 upon R1 multiplied by V1. Right? This everybody knows. Non-inverting amplifier. Gain is 1 plus R2 by R1. And directly you can apply this. Right. 2 multiplied by 1 plus R2 is 2K, R1 is 1K. So 2 plus 1, 3 into 2, positive 6 volts. Done. Let us see why it is 1 plus R2 by R1. Since no current into the op amp, 0 amperes, these two resistors are in series, right? R2 here, sorry, R1 here, R2 here, this is my, and this is my V minus point. Okay, this point. Is that okay? And this branch current equal to 0 amperes because no current into the op amp. But the feedback is negative, right? The moment feedback is negative, V minus equal to V plus or V plus equal to V minus, and that is given as V1 here. So this V minus should be equal to V1, right? And V minus, you can apply voltage division rule here because this branch current equal to 0. So V minus is equal to V out multiplied by R1 divided by R1 plus R2. That is a simple voltage division rule. And that value V minus should be equal to how much? V1, right? So what is V out? V out, rearranging this R1 plus R2 upon R1 multiplied by V1. That is nothing but your formula here. R1 upon R1, 1 plus R2 upon R1 multiplied by V1. Then, right? And if you are not remembering the formula, it's quite simple. How much voltage will be available here? 2 volts, V plus equal to V minus. And how much is the current flowing through 1 kilo ohm in this direction? 2 minus 0 by 1, 2 milliampere. Then no current into the op amp, no current from the op amp, input side of the op amp. So 2 milliamps flows through this. It's quite simple. And you are dropping a 2 into 2, 4 volts. Right? And if you are subtracting 4 volts from output, how much you should get? 2 volts. So if you are subtracting 4 volts from output, you should get 2 volts. So output is nothing but 6 volts. You need not apply the formula. By looking at the circuit, you can easily identify current point through 1K is 2 minus 0 by 1K, 2 milli. 2 milli flows through 2K also. 2K into 2 milli is 4 volts. So if you are subtracting that 4 volts from output, how much you will get? Same 2 volts. So output should be 6 volts. No issues. It's trivial, clear. Formula may not be work always, but this method, logical method, will work always. Right? So output is nothing but 6. It's very simple. Right? And let us see another one. Here, how much it will be? Same thing, same circuit, 2K, 1K, 2K. So if I am adding one more resistance here, right? Let us say 1K, and this is 2 volts. How much will be your V out? Quickly, hardly will take 5 to 6 seconds. Everybody. Right, Sanjeev says 3. Right, very good. What about others? Right, looking into the circuit answers. No need. This op amp you can learn in the class. You need not do anything at your home. Just listen to the class, try all the problems, write online examinations. If that will complete level advance. No other words. All right, what about others? Right. Okay. So you'll be having, some of you will be having doubt how to solve this, how to solve it quickly. Let me explain. Is there any current into the op amp? Oh, this is 0 amperes. No current into the op amp. Implies same current flows through these two 1 kilo ohm resistors. So it's a kind of circuit like this. Two at the end, this is grounded, ground, and this is my V plus. Resistors are equal, 1K and 1K. Then what about my V plus? It divides equally. 2 into 1K divided by 2, so 1 volts. So this is 1 volt. Then negative feedback, V plus equal V minus 1 volts over 1 minus 0 by 1K, 1 milliampere. Finished. Current point through 1K. Same current flows through 2K, 1 milliamps. Right? Voltage across 2K will be 2 volts. Then in the polarity given. So if you are subtracting 2 volts from your V out, you should end up with how much? 1 volt. So V out should be how much? 3 volts. Right. Very good. Or still, if you're having any confusion, V plus is equal to 1 volt. So this entire circuit can be replaced with our old circuit with 1 volt plus 1. 1 volt multiplied by 1 plus R2 upon R1 is my V out. 2 by 1 is 2 plus 1, 3. 3 into 1 is 3 volts. Both ways it is correct. But the earlier one is you can looking into the circuit, you can identify V out. Is that clear? Okay. Anybody, any problems? Any issues? Right. Let me get into the another one, another circuit. Any problem? Others? Any problems? I should be repeat anything. Right. Just put a Y in your chat box if you're comfortable. Right? Clear? Right. Next problem, we have another one. And I have written V out equal to 4. Let us verify that. And you cannot apply your formula. You have to logically solve this. 1 plus R2 by R1. R1 is not available. Instead of R1, you have current source. Negative feedback. So V plus equal to V minus. Implies at V minus with respect to ground, you will have 2 volts. Because V plus equal to V minus due to the negative feedback in the circuit. Right, and then I say 4, right. Okay, 4 answer I have written. Please verify that whether it is 4 or not. This is also quite simple. No work. 2 seconds is required. 2 milliamperes should flow through 1 key. Right? Why? There is no current into the op amp. There is no current from the op amp. 2 milliampere flowing through 1 K will generate how much volts? 2 volts. Right. Don't confuse while writing this of voltage law. We are going to identify V out with this polarity. Right. This is not at ground now. This is at 2 volts with respect to ground. So I have redrawn this potential 2 volts with respect to ground. So starting from ground, negative, positive V out. Plus minus, positive, negative. So I should take a negative 2. Plus minus, I should take another negative 2. I am starting from ground, reached at ground. Say closed loop equal to 0. V out equal to plus 4 volts. Done. No issues. Hardly to take 4 seconds. Right? Everybody could answer. Any issues? All right. All right. Let us get into the copied. Copy samay badao. Yes. Okay. I'm moving to the next slide. Copy. Right. Here I have different cases. Okay. So case number 1. Let us do case number 1 first, then case number 2. What is the output voltage? Case number 1 first, then case number 2. Remember, you will get always a question from a PAM that will hardly requires 5 to 6 seconds to solve. You will get 2 marks. Answers. So answers are a little bit late. So let me help you out. Right? Is there any current into the PAM? No. Infinite impedance. Current flowing through R is 0. Voltage drop across R is nothing but 0 volts. True. So how much will be appearing at V plus? 2 volts here. Minus drop, that is 0 volts. So 2 volts will appear at your V plus. Ashwin says 4 and 0, right? Very good. Right. 4, oh, G Smaja said 4 and 0. Right. Very good. 2 volts here. Okay. And negative feedback, this should be 2 volts. Right? This is V out. 2 equal resistors, R and R. This is V out. And this I understood it as 2 volts because it will be minus this end is grounded. Then how much should be my V out? To get 2 volts between equal resistors, I should apply how much? 4 volts. So this is nothing but 4 volts. Then no issues. Right. Very good. Right. What about second one? 4,0. Right. What about others? Second case. Is there any current into the PAMP? No. 0 amperes. Drop across R. 0 volts. 2 is available here with respect to ground. So V plus will be how much? Same. 2 minus 0. 2 volts itself. And the feedback is negative. How much should be my V minus? V minus should be equal to V plus. That we got it as plus 2. So this should be 2 volts. Right? That is same as our earlier case. 2 equal resistors. Instead of ground, I have how much? 2 volts. This is 2 volts. And this is V out to be identified. And here I should get how much? 2 volts. Equal resistors R and R. That should be my V out. This Maria said 4,0. Ashwin said 4,0. Right. So 4,0 and so was wrong. Right. So those who said 0 initially, please do correct it. Yeah. Yes. It's trivial from the circuit diagram. Output should be 2 volts. I don't know why you end up with a 0. Let us elaborate. No issues. Commit all the mistakes in the class, and while writing the gate examination, reduce your mistakes. You cannot avoid the mistakes. Mistakes will be there, but you can reduce it. Right. The case here, I can explain using the circuit diagram quickly, then I will get to this. So this is 2, this is 2, this is also 2, implies this end is a 2 volt, this end is also a 2 volts, potential difference is 0, 2 minus 2 equal to 0, no current flows through R, and hence no current flows through the second resistance R, no drop across this R 0 volt, no drop across this R 0 volts. Here 2 is available, 2 volts with respect to ground. 2 minus 0 minus 0 will be my V out, that's equal to 2. Or the other way, if you are confused, this is positive 2 volts. This V out I have to identify, and equal resistors, and I know that this node voltage should be how much? 2 volts, right? How to find that? No current to this branch, it's open. And this V out will appear as this node to ground out. These 2 volts will appear like this with respect to ground. 2 volts. And I have a same current in the circuit. And that current will make I times R drop here, another I times R drop here. So if you are adding plus minus IR along with 2, I will get out. Right? So what is I? I is nothing but potential difference. Here it is V out minus here it is 2 divided by total resistance 2R. And you will get V out as positive 2 after solving this. That is likely, not true. Or to get a 2 volts here, this drop should be 0 volts because the same 2 will appear here. So I should be equal to 0. So you can equate this to 0. So 2R 0 will be 0 equals V out minus 2 implies V out is equal to 2 volts. Then if I am adding IR with 2, I should get this 2 volts. So this is 2 IR. So I should be 0. To make I equal to 0 here, V out should be equal to how much? 2. So I go it as 2 volts. Right. Oh, right. Any other issues? Anybody without understanding this? Right. Okay. Any other issues? Any problems? Right. Anybody, please let me know if any other clarifications are required. You are paying the money and we are serving you. At any time, you can ask your doubt. It's your right. And those doubts I could clear, I will make it. Otherwise, I will say I don't know. So there are no restrictions in asking doubts. Any doubts you can ask. Right. And this is more lengthy, so I'm leaving this. I will explain this one using the circuit. Right. Listen. Right. I'm splitting it up equal resistors, 2 volts and 2 volts. This was 2. And I can connect separate 2 here, both are 2 volts, 2 volts, same resistors. No current into the op amp. Can listen? No current into the op amp. So this end is 2 volt with respect to ground. No current implies 0 voltage drop. So V plus is equal to positive 2. Is that clear? Since negative feedback B plus equal to B minus implies this should be also at the same potential as that of B plus. B plus is at 2, so B minus also should be at 2. This end is 2 volts, this end is 2 volts, so no current flows through the resistor R. Current is 0 ampere because potential difference across its terminals equal to 0. So there is no current flows through upper R also because op-amp cannot supply current at the input side. Also no current flows into the output. So there is no voltage drop across this R. Voltage drop across this R is also 0 as we discussed earlier. Right? So as far as this circuit is concerned, I have a 2 volts here with respect to ground. So this is nothing but like this, 2 volts. And output I have to identify that is appearing like this. This is the ground. I am moving from ground, negative to positive, plus 2. And this is 0, 0. This is 0, 0. I have reached here. To ground I have to reach. So plus minus, I should write minus. V out equal to 0. Closed loop, ground to ground. So I will get V out is equal to positive 2 volts. Is that clear? Calculation, yes. Of course, you have a resistance here, no issues. So I'm moving around this loop to identify V out. Right, okay, clear. Let us move to the next one. Identify answers. Same principle, nothing else. Negative feedback, V plus equal to V minus, identify V plus, equate with V minus, then identify V out. That's it. Right, Sajid says, very good. Right. What about others? Abhishek given as 0, Ismail as 0, very good. What about others? Please tell me how much is your V plus? V plus. No current into the op-amp. Same current goes through these two resistors. This is 2 volts, right? Equal resistors at midpoint. I will have half of the total voltage. 2 is the total voltage. Equal resistors. I will have a 1 volt at my V plus, positive 1 volts. Correct. 1 volts. അത് ക്ലിയർ അല്ല അതിൽ എന്തെങ്കിലും പ്രശ്നങ്ങളുണ്ടോ ബി പ്ലസ് വൺ ആയിട്ട് പ്രശ്നങ്ങൾ എന്തെങ്കിലും ഉണ്ടോ ബി പ്ലസ് ഇക്വാലിറ്റി ചെയ്യുമ്പോൾ രണ്ട് റെസിസ്റ്റേഴ്സ് ആണ് ഈക്വൽ ആണ് അപ്പർ എൻഡ് പ്ലസ് 2 ആണ് ലോവർ എൻഡ് ഗ്രൗണ്ടഡ് ആണ് ഈ പോയിന്റ് ആണ് എന്റെ ബി പ്ലസ് ഈ ബ്രാഞ്ച് കറന്റ് 0 ആംസ് എന്ന് എനിക്കറിയാം സോ ജസ്റ്റ് എ വോൾട്ടേജ് ഡിവിഷൻ റൂൾ 2 multiplied by r voltage across r divided by r plus r 2r will be my v plus r will get cancelled with 2 equal to 1 right? Yeah. And that should be my V minus. So I am removing this. V minus should be also equal to 1, right? Others who didn't answer, please decide. This is 2 volt as such. This is my 1 volts. That 1 volts should appear like this. V plus equal to V minus, right? 90 degree. It's very easy to identify that. So the upper one end of this resistance is at 2 volts with respect to ground. So 2. This end is at 1 volt. So current point through this will be 2. This end voltage is 2 minus this end is 1. So minus 1 by R. That's equal to 1 by R. So this current is nothing but 1 by R. No issues. Very simple. and the same current goes through this, right? 1 by R, because no current going into the path. So 1 by R goes through the second R. 1 by R multiplied by R, 1 volt in this polarity. Then my voltage should go out. Negative positive plus V out. Negative positive plus 1. Plus minus. I have started from ground. I should reach a ground. So I'm traveling like this up to ground. Negative positive plus V out. Negative positive plus 1. This is plus minus 1. So that is minus 1 equal to 0. Implies V out equal to 0. Simple. I have identified V plus as 1 volt based on voltage division rule. That V plus should be appearing at V minus because negative feedback, right? So I have marked with the voltage source. Then I went for a jump around this and I got it as 0. Is that clear? Any issues? Actually, said 0. What about others? Everybody got 0? Or any confusion, any issues? Please put a Y in the chat box so that I can move to the next. Doesn't matter. മനസ്സിലാവാതെ ആരെങ്കിലും ഇരിക്കുന്നുണ്ടെങ്കിൽ അവർ ചോദിക്കാം. മനസ്സിലാവാതെ ക്ലാസ്സിൽ ഇരുന്ന് നമ്മുടെ സമയം മാത്രമേ നഷ്ടപ്പെടുള്ളൂ. കൺസ്ട്രെയിൻസ് ഒന്നുമില്ല. എപ്പോ വേണമെങ്കിലും ചോദിക്കാം. ടൈപ്പ് ചെയ്യാൻ ബുദ്ധിമുട്ടുണ്ടെങ്കിൽ അൺമ്യൂട്ട് ചെയ്ത് ചോദിക്കാം. ഓപ്പാമ്പിലെ എക്സാമിനേഷൻ വരുന്ന ക്വസ്റ്റ്യൻസ് എല്ലാവരും കറക്റ്റ് ആയിട്ട് ചെയ്യാൻ പറ്റണം. 2021 ഗേറ്റിൽ അപ്പീൽ ചെയ്യുന്ന ക്വസ്റ്റ്യൻസ് അതിന് വേണ്ടിയാണ് ഇത് പഠിപ്പിക്കുന്നത്. മനസ്സിലായില്ലെങ്കിൽ അപ്പോൾ തന്നെ പറയാം. റൈറ്റ്. മോഹൻ കുമാർ KS, any issues? Okay, right. Let us move to the next slide. Next, I have put the heading. Before that, I will ask you to solve one problem. Then we'll go to that sample. Like this. I will give you that. Identify V out of the circuit shown below. Identify V out. Right, everybody says -2. Very, very, very good. What about others? Please to answer this. This was the question once appeared for 8, for 2 marks, I think. Right, Mohan Kumar says -2. Right, Maria Sami -2, Sneha -2. Right. What about others? Please, it's very true. Any other answers other than -2? Right, okay, everybody got -2. What about others? Different answers or -2? There are around 75 students, hardly 20 to 25 replying. I don't know why. It's very convenient. No, you are not in the class. I'm not going to see who is sending the messages. You can simply type it. Nobody will know what to type. Right, I'm not observing anybody. Okay, -2, Bhagilakshmi -2, right, very good. So I have -2, right. Right, this Maria -4/3, right. What about others? Shipa -2, right, very good. Paul got how much? Plus -4. What is the answer of Paul B? Aravind -2, right. All right, okay. And Bharat got -3. That is a different answer. Okay, right. We'll see that. Right. You, all of you are so lucky that it's a virtual class. Otherwise, everybody was sitting in the class. I could have beat you. What is the voltage available here at the point? Is it 1 volt? That is why I said I could have beat you all who gave -2 answers. Is it a 1 volt? Three of you had a complete virtual course. Is this is a +1 volt? Dear students, you please understand that if this branch is open, then only you will have same current going through both resistors, right? Then only you can apply voltage division rule and you will get it as a 1 volt. If a branch is connected here to which potential? Ground, right? V plus equal to V minus. Ground. Another one. This is ground. This potential is not 1 volt. The equivalent resistance will become how much? R and R in parallel by 2. Right? Or since there exists a branch and that current not equal to 0, we cannot say that this potential is 1 volt. Right. So the now is saying 1/3. Right. So if I'm calling it as a node voltage, X, I have 3 branch currents, right? One is going towards right, another one let us say up, another one let us say all are leaving, right? And this potential is Vx. So the first current, let us say I1, is nothing but Vx minus 0 by R plus the current leaving up. Second branch is how much? Vx minus 2 by R, which of current low at this node. And you should not eliminate the third branch current, you should write it. Third branch current is Vx. This branch current is Vx. What is the potential here? 0 volts. So Vx minus 0 by R. All the sum should be 0. All leaving currents should sum to 0. Alright. Yeah, now you are saying that the -1/3, that is right. Right? So what is the value of Vx? R will go to right hand side 0, product will be 0. I have 1 Vx, 2 Vx, 3 Vx, right? 3 Vx minus 2 equal to 0. Vx equal to 2 by 3 volts. Once that is known to us, then you can replace with an inverting amplifier. This voltage is how much? 2 by 3rd. Right? 2 by 3rd volt. Then it is an inverting amplifier. V out will be minus R2, that is 2R divided by R1 is R multiplied by V in. V in is positive 2 by 3. R will cancel, so minus 4 by 3 volt is the right answer. And this is my answer. So while evaluating the node voltage, while applying Kirchhoff current law, your answer will be right mostly. If you are going for a voltage division rule, please remember that the third branch current should be 0, so that both elements are in series. If both elements are in series, then only you can apply voltage division rule. Is it clear? Any doubts? Is that okay? Yeah. So please don't go wrong. Stick on to your basics. Never lose what you have learned in the class. Stick on to KCL and KVL always. Right? Again, I'm repeating. If you are going to apply voltage division rule between n number of elements, those n number of elements should carry same current. They should be in series. Right. Okay. Then let us get into our inverting summing amplifier. Inverting summer. Inverting sum. So you need not by heart any formula for inverting summer. We will derive it. We will write out the equation based on inputs Vx, Vy, and Vz. Case number 1 and case number 2. Resistors are R, 2R, 4R. Feedback resistor is 4R. First thing you have to observe is the feedback is negative. Once the feedback is negative, you can mark it as a ground, V plus equal to V minus. Then partially the solution is over. Once V minus equal to 0 implies, you can directly solve the circuit. I have three currents. I will mark it as Ix, Y, I, Z. Three voltages, and I have named it as an inverting summer. Let us see whether it will function as an inverting summer or not. Vx, Vy, Vz. I have three currents, Ix, Iy, and Iz. All these currents flows through this branch and cannot flow into the ramp, 0 amperes. It should flow through the resistor for R. I equal to the sum of the currents Ix plus Iy plus Iz. It's very simple. Right? Three branch currents will sum up, and that entire current I will pass through R. And that current will generate a voltage of I times or 4I times R, 4IR, having a polarity like this, plus minus. Right? Negative, positive. Right? And this is my V out. This is here. This is also. So this is my V out. As earlier, if you are going to find V out, you have to write a KVL around the loop. Negative, positive, plus V out. Negative, positive, plus 4 times I times R, or 4R times I. And have reached the ground here. I have started from here, ground, V out, then voltage drop across 4R resistor, 4R. Then I have reached the ground. That's a closed loop. That's some should be equal to 0. Implies V out is nothing but minus negative of 4 times I times R. And my I is the sum of Ix plus Iy plus Iz. Ix is nothing but, based on Ohm's law, this potentially at 0, this is also at 0 volt, this is also at 0 volt, 0 volts. V plus equal to V minus, V plus is grounded, V minus is also at ground. So Ix is nothing but Vx minus 0 by R plus Iy is Vy minus 0 by 2R Vz minus 0 by minus 0 by 4. That is my current I. Right? It's very simple. So V out is nothing but that current, that is Vx by R plus Vy by 2R plus Vz by 4R, that current multiplied by how much? 4 times R. So R and R will get cancelled. So it will become with a negative sign, negative sign, negative sign. So it can be simplified as, of course, we'll have 4 different options. One option will be the right choice. So V out is nothing but minus 4Vx minus of 4Vx plus 2V1 plus Vz. So it's summing with an inversion sign. So it's an inverting summer. They will ask you, they will express V out for the circuit. Let us mark V out equal to minus Kx Vx plus Ky Vy plus Kz Z. They will ask you what are the values of Kx, Ky and Kz. Not identified. So Kx is nothing but 4, Ky is 2, Kz is 1. Right? So that the name is inverting summing. Any issues, any problems? You are writing branch current, summing it, taking the product, evaluating V out. Any problems, any issues? Case number 1. What about case number 2? What is V out? So you can copy this. I will do it. You can copy this. Answers. We found individual branch currents Ix, Iy, Iz in terms of Vx, Vy, and Vz. We could find it easily because positive input was grounded, negative input also virtually at ground, zero potential. So Ix equal to Vx minus 0 by R, Vy minus 0 by 2R, Vz minus 0 by 4R, Z. Adding together, multiplying with 4R with a negative sign, R will get cancelled. Right. What about second case? Second case, Vz I have put at the positive input. And the feedback is negative. Implies V minus also equal to at the Vz. V plus equal to V minus. Right? And there is no current flowing through 4R. Why? Because potential difference across 4R is Vz minus Vz. Both are same. Potential difference is equal to 0. So no current flows through this branch. So you can remove that branch, or the current contribution from this branch by this branch equal to 0 amperes. Then you have two branches more, Vx and Vy, and ultimately you will have same thing for Vx and Vy. So minus 4Vx plus 2Vy, and your Vz term won't be present. Is that right? Is that right? So current supplied by the third branch is equal to 0. Then you have to find the output. Is it minus of 4Vx plus 2Vy? Is it true? Is it true? Is it true? So we have two active branches. This is at PZ. This was PZ, Vy, and Vx, and their values are R2, R4, R2, R, and 4R. Combining this, connecting like this is 4 times R. This is my V out. So this is Vz. This is also at the Vz potential, right? V plus equal to V minus. So there is no branch current through 4R and Vz. I have two currents, Ix and Iy, and that current I flows through Ix plus Iy flows through 4R, right? So what about my V out? I am going to measure V out like this. What is my V out? I should write KVL around the loop. Polarity is plus minus here, right? Ground, I should reach it ground. So negative to positive plus V out. Negative to positive plus I times 4R, right? Then I have reached here, I have to reach ground. So plus minus Z. So minus Z equal to 0. Right? So V out is nothing but Z minus 4IR. It's equal to Vz minus 4R multiplied by I. How much is I? Ix plus Iy. Ix is Vx by Vx minus Vz by R Ix plus Iy. Vy minus Vz by 2R. Because this potential is at Z. Current flowing through this R is Vx minus Vz by R. Vx minus Vz by R. Second branch current is Vy minus Vz by 2R. That is my. So simplifying this, the out is equal to, we said R and R will cancel each other. Right? Minus 4 times Vx minus Vz plus Vy minus Z by 2. So I can write it as minus inside the bracket 4Vx 4 times Vx minus Vz plus Vy minus Vz multiplied by 2. Right? So this can be written as V out equal to minus of Kx Vx as earlier, Kx Vx plus ky plus kz dz. And please tell me what are the values of kx, ky, and so that went a bit lengthy. Don't worry. So they will ask you to identify kx, ky, kz values, coefficient corresponding to vx, vy, and vz. Please post your kx, ky, and kz values. Different answers will be problem for me. 420, 42 minus 6, 42 minus 7, 42 minus 7, 42 minus 7, 42 minus 7. Right. So minus 7 will be the. Okay, 4, 2 minus 7 or minus 2 minus 4, 7, no problem. If you are putting an inversion common, you will have 4, 2 minus 7, otherwise minus 2 minus 4, 7. That's similar. So I will have a 7 here. 7 here. Ky, I will have 2. Kx, I will have 2. So 4 options will be there for kx, ky, kz. Like this. 4, 2, minus 7, minus 4, minus 7, 2, 4, minus 7, 7, minus 2. 4 different options will be there. And if output is expressed like this, you can go for 4 to 7. Oh, sorry, minus 4, minus 2, 7. So minus 4, minus 2, 7. Then go to a second. This. Right. Okay. Let us get into one more numerical problem based on my inverting summer. I have a circuit like this. You are asked to find out the value of V out. I'll give you 2 minutes. You can comment on your answers. Right, so you say minus 14, minus 14. Any other answers? All of you please try this. Everything you have learned. Answer the question. Right, others. Take your own time and you should answer. 1 and 3 is out, minus 17. Okay, Sachi, corrector 2, minus 12. Okay, right. Others? Right, so different answers, very good. Minus 1.5, minus 3 by 2, right, minus 3. Can you please tell me what is your V plus? That everybody, what is your V plus? This is my V plus, simple voltage division rule, because this branch current equal to third branch current equal to 0 amperes, idea of amp. 3 volts multiplied by 2R divided by total resistance 3R. R will get cancelled, 3 will get cancelled, 2 volts. So negative feedback, this will be also at 2 volts. Right. So this potential is 2 volts with respect to ground. 2 volts. Since this is at 2 volts, the branch current going to the first branch will be 0, 0 here. 4 minus 2 by 4R, this current will be, I will mark it as I1. I1 will be 4 minus 2 by 4R, 2 by 4R, that's equal to 1 by R. I2 equals 6 here, 2 here, 6 minus 2, 4, 6 minus 2, 5, R. So 4 by 4R, 1 by R. These two currents sum up and goes through R. So value is 1 by 2R plus R. So 1 by 2R plus 1 by R is the current going through R. That will drops the voltage in this polarity. Voltage will be how much? Current multiplied by the resistance. So 1 by 2 R will cancel plus 1. So that is nothing but 3 by 2 volts. Is the answer is minus 3 by 2 volts. And this is my out. Okay, again answers are different, right? Minus 0.5 plus 0.5, let us fix it. Minus 0.51 plus 0.5. Right, let us write KVL around this group. Then the issue can be resolved. Starting from 0, ending at 0. So negative to positive plus V out. Negative to positive plus 3 by 2 volts. Plus minus minus 2 equal to 0. It's a closed loop starting from 0, ending at 0. So V out is nothing but 2 minus 3 by 2, that's 0.5 volts. So V out is positive 0.5 volts. So minus 0.5 is wrong, I guess. Right? V plus is 3 only, 2 only, right? 3 multiplied by 2R divided by 3R. We cancel 2 volts. So minus 1.5 plus 2 That is plus 0.5. Is that plus 0.5? Please comment. Plus 0.5 is right. Yes or no? Plus 0.5 is right. Right. So let us wind up the session after doing one more. It's a non-inverting sum. Identify V out. It's very simple. So for making it easy, let us assume this is 1 volt, this is 2 volts, this is 3 volts, R equal to 1 K, 1 equal to 1 K, R2 equal to 2 K, R3 equal to 3 K. All values are here. First point is to identify the feedback. Feedback is negative. V plus equal to V minus. V minus is connected to V out. So this will be V out. This also will be and V out is unknown. Our 3 branch currents here is I1, I2, I3. Answers. All right, 18 by 11, 18 by 11. Right. What about others? It's very, very simple. Write one nodal equation and solve for V out. That's it. Current flowing into the op amp should be how much? 0 amperes, because it is an ideal op amp. So I1 plus I2 plus I3 flowing through this branch, and that value should be equal to 0. So recently you can equate I1 plus I2 plus I3 equal to 0. That is true, because these 3 branches send a current to the 4th branch, and that branch current should be 0, right? And I1 is nothing but 1 minus V out by 1K. I2 is nothing but 2 minus V out by 2K plus 3 minus V out by 2K. Sum should be equal to 0. And just you want to solve this. Taking the LCM, 6 times 1 minus V out plus 3 times minus V out plus 2 times 3 minus V out equal to 0. Equal to 0. How much we're getting after solving for this? Solving this, we out. Is it 18 by 11? Is it 18 by 11? Right. Okay. Right. Sorry. So after seeing the big circuit, you need not worry about that. Apply what you have learned and solve for the output. Okay. Let us wind up for today. Tomorrow we will continue with the more tricky questions and circuit with the positive feedback and balanced difference amplifier. Right. So let us wind up today. Thank you for listening to class. Thank you for sitting. Thanks a lot. We'll meet tomorrow, 10 to 12:30. Right? If you have any doubts, you can ask me. Unmute and you can ask me. Any issues? All right. Oh, hope it was clear. Thanks a lot. Thank you for sitting in the class. Thank you.